Hey, welcome back everyone. So the next topic for chapter 2 is going to be chemical bonding. So when we take two atoms and stick them together, we form a bond. And that bond is going to form a molecule. Now, if we go to slide 4 of the handout, you're going to see chemical bonding, and it says we have handout 2C, which we're going to get to in just a second here. But the slide is going to show us that when we form a chemical bond, we actually create a molecule that contains energy. The chemical bond is going to store energy. And so there it says chemical energy is a form of potential energy in a chemical bond of a substance. So that bond holds energy. And what's going to happen is if we take a molecule and we break those bonds, we're going to release energy. And so what happens when we eat food is that food is made up of molecules, carbohydrates, fats, proteins. Let's say we eat a carbohydrate. That carbohydrate is a string of atoms bonded together to make that carbohydrate molecule. Our body is going to break the bonds of the carbohydrate molecule, and that's going to release energy that we can use in our body. Now that's a brief kind of explanation of how we get energy in our body, and we're going to cover more about this as we go through this chapter and as we go through this class. But let's focus on handout 2C and talk a little bit more about chemical bonding. Okay, so here is the handout, and we want to focus on two major types of bonds for this class. The first type of bond is called an ionic bond, and an ionic bond is a bond where we form a molecule, two atoms bond together, but an ionic bond is going to create these atoms called ions. Ions are charged atoms. And I mentioned this in a previous video that ions are going to be a part of our body, and our body utilizes ions to run systems like our muscles and our nervous system. Well, to make an ionic bond, what we need are two atoms that are going to bond together. But when this bond occurs, we're going to give up or take an electron from one atom and give it or get rid of it from another. Now let's look at this example. This is sodium and chlorine. What we're going to do is we're going to take sodium and chlorine, we're going to bond it together to make salt. So sodium chloride, NaCl, is just table salt. Well, our body uses salts, and this is an example. So what happens in an ionic bond is this sodium atom is going to give up an electron and give it to the chlorine atom. So when that happens, the sodium atom is going to lose an electron. It's going to give it away. This electron is going to go to chlorine. So then chlorine has an extra electron, and sodium is missing an electron. Now remember from my last video, I said that protons and electrons in an atom are usually the same. So if I've got 6 protons, I usually have 6 electrons. If I give one away, or if I take one and add it, I'm going to start making charges. So for example, sodium has 11 protons and normally 11 electrons. But if I give away one of these electrons, now I only have 10 electrons. So I'll have 11 protons and I'll have 10 electrons. I'll have one more positive than negative. That makes this sodium a plus, a positive. That's how we get this ion. Now, chlorine added an electron. So it has an extra negative electron, and that is going to make it negative. So now we've got two ions that can form when we make a salt. We have a positive ion, in this case it's sodium, and a negative ion, which is chlorine. Now, our body can actually dissociate these and start using these ions for certain purposes, like running our muscles or running our nervous system. So these are just some examples. Anytime you see this plus sign or this minus sign next to the symbol of an atom, it represents an ion, a charged atom. And remember, I told you in the last video, cations are deemed positive, anions are negative. So this is an ionic bond. Ionic bonds occur when a metal bonds with a non-metal. Okay, now the second type of bond I want to talk about is a bond called a covalent bond. Covalent bonds are going to be sharing an electron. So instead of giving up an electron, we're going to share the electron. So a perfect example of this is water, and you can see I've got a water molecule. This water molecule, the hydrogens are going to share the electrons, and each atom will have that electron for a certain amount of time. Covalent bonds are the bonds of life. So this is what our body is put together with. So those molecules of life, carbohydrates, proteins, fats, they are made by covalent bonds. Now it says covalent bonds can be single, where we just share one electron, like in this water molecule, the hydrogen and oxygen is just sharing one electron. Or we could have a double bond. Molecules that are made by covalent bonds can be nonpolar, which means that electron is shared equally. So if the molecule is nonpolar, it has no charge. Or it can be polar, where the electrons are shared unequally. The case of water, it is a polar bond. So what happens is this oxygen atom is going to steal that electron a little bit longer than these hydrogen atoms. So what happens is, if the negative electron is hanging out in the oxygen more than the hydrogen, we're going to get a polar or a charged molecule. So in the case of water, these hydrogens don't have that electron as much, so they become positively charged because they don't have that electron as much as they want. The oxygen is stealing that electron a little bit longer, so the oxygen side becomes more negative. And what we've got is what we have what we call a polar bond. This is why water loves to stick together. So the negative oxygens will love to stick to another water's hydrogen. And so we get sort of an attraction between molecules. Okay, so that's a little crash course in the bonding of atoms. So atoms can bond together. Covalent bonds are going to be our bonds of life. So they're going to be making our biomolecules that actually build our body. We'll get to that later on in the chapter. So Hope you're having a good day, and I'll see you later. We'll move on to handout 2D next.